So LSTM, in this video we'll discuss mainly about notations used in LSTM. Right? So this is the recurrent neural network box representation which we have seen already. Right? So here we have this operation which sums the product of this output with this weight and this weight with this input, right? And then we are applying this function on this sum of the products, right? And then we are getting the output of this particular time step. And when there is no word left, there is no input left, we produce the final output, right? So this is the box representation of the LSTM, where we have notations like this is the output coming from previous time step, this is the output of the current time step, right? And this is the input to the current time step, and this is the final output. Weights are here W1, W2, and W3. So now let's see the LSTM notations. What are the notations used in LSTM? So this is how LSTM is LSTM unit or cell sorry, LSTM cell looks like. And this is called a cell here, right? This box here is called as cell in LSTM. Now this CT is nothing but the output OT, which we are producing the output of this current state or current time step. So this YT is the final output, is similar to our YI hat, right? Why this that particular y, I can call it as YT, or output of that particular time step, right? And the final output which we are getting, this y is similar to our this HT is similar to our YT, right? This one, this one, this one, right? So, and this CT minus 1 is the output of previous time step OT minus 1, right? This is called as previous cell state. CT stands for cell state. What is the current cell state, right? So this is previous cell state, and this is equivalent to our YT minus 1, right? YT minus 1, right? So that is the output of previous cell state, right? So in short, the C is equivalent to O, which we have seen. H is equivalent to Y, and XT is equivalent to XI, which we had. So the other notation here is this is the concatenation operation. This operation we had seen this product, but here we have this concatenation. In concatenation, what happens is, if I have one vector here, one, or if I have one string here and other string, when I concatenate these two, I just append this at the end of this, like this. This is concatenation operation, right? Putting this at the end of this, right? This is concatenation operation, like this, vector concatenation. You see, we have two vectors here, U and V. These are coming here, and they are getting concatenated. We are putting the second vector at the end of the first vector, right? So now, so so this is one operation, concatenation operation, which is used here. The other important operation is this. This is called as pointwise multiplication, right? So pointwise multiplication, that means if I'm giving two inputs to this, like this, and this is, let's say, 1 1 1, right? And this is, let's say, 1 2 3. So what this pointwise multiplication does is it multiplies this with this with this with this, right? And this with this, right? This is called as pointwise multiplication. This with this with this, and this with this, right? Similarly, I have the another operation called as pointwise addition. So this pointwise addition adds, rather than multiply. If I have this addition here, addition, this will be added with this will be added with this will be added with this, right? So that is pointwise addition, pointwise multiplication, pointwise addition. And there is something called as pointwise, this operation here, if you are able to see, this is called as tan h. This is pointwise tan h, pointwise tan h. So what is pointwise tan h? So to this tan h unit, or this to tan h function, let's say I am giving this as input, uh, this 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 vector as input, this this vector as input. So what this tan h does, when I give this as input, so this tan h gets applied on individual element like this, right? So tan h will be applied on this, and tan h will be applied on this, and tan h will be applied. And then the output which I get is, so this output is the result of applying tan h on this, right? So this one, tan h. So this output here will be the result of applying tan h on this element here, right? So this output here will be the result of applying tan h on this, right? And this here will be the result of applying tan h on this, right? So this is called as pointwise tan h. This is not a tan h layer. This is not a neuron layer here. It's a tan h operation, pointwise tan h operation. Okay. Now the other things here are these. If you see a yellow box, this is the neural network layer. For example, this is a neural network layer with sigmoid activation functions. So this is a layer of neurons with sigmoid activation function. Yellow box means neural network layer. So this is again a neural network layer with sigmoid activation function. This is again a neural network layer with sigmoid, tan h activation functions here. This is a neural network layer with tan h activation functions, right? So these now when we see these ping boxes, as we have discussed already, they are the pointwise operation. Pink boxes are the pointwise operation. Yellow boxes are the neural network layer, and these arrows are just vectors. These are the arrows are just vectors. I have an arrow here. I have an arrow here, right? And then this is the concatenation operation. Concatenation operation, right? We are concatenating the vectors coming from here and here, right? Then this copy operation, this is copy operation. Now if you see here, we are when we have this kind of operation here, right? So this whatever output we are getting from here, it is getting copied here as well as here, right? It is going here as well as here. This is just copy operation. So these are the notations here, and the symbols which we already discussed. This CT is equivalent to O, C is equivalent to O, right? H is equivalent to Y. H is equivalent to Y, which we have discussed in RNN, right? Now this FT is the output of this, I is the output of this, and CT hat, CT bar, this is CT bar, right? CT tilde, it's not bar actually, it's tilde, it's this kind of operation. CT tilde is output of this, and then this OT is not equivalent to, is not this OT, is not this O, but OT is output of this particular layer. So if you look carefully at this LSTM unit, there are three operations here. There are three gates, they are called as this one, this one, this one, and this one. So we'll discuss this in the these gates in the next video, but I hope the notations are clear in this video.